Hi everyone,
Hi
I am
everyone,
Lakshmi
I
Chibi.
am Lakshmi Chibi. Now I am going to explain
Priority scheduling.
priority scheduling.
The CPU
The
scheduling is
CPU
one of the
scheduling is
most
one of the
important
most
tasks
important
of
tasks
an operating
of an
system
operating
because
system because
it
it
decides which process
decides
should
which
use
process
the
should use
CPU
the
at any
CPU
given
at
time.
any given
Good
time.
scheduling helps
Good
the system
scheduling
run
helps the system run
more
faster,
efficiently.
smoother, and more efficient. There are many scheduling techniques like FCFS and SGF and SRTF and round robin. But in this project, we focus on priority scheduling. In this method, we process is given a priority scheduling and the CPU always selects the process with the highest priority. However, priority scheduling has a major drawback called starvation. This happens when low priority processes keep waiting because new high priority processes keep arriving and they never get a chance to run. To solve this problem, our project has an aging mechanism which slowly increases the waiting for long time. This ensures the every process eventually gets CPU like time, making the system failure. The main goal of this assignment is to design, implement, and improve the priority scheduling algorithm using aging and then test it using different sets of process by comparing the results with and without aging. We can clearly show the improvement and justify why aging is a experimental setup. Programming language used the priority scheduling algorithm was developed using C as it provides low-level controller, efficient memory programming management, and precise timing which are useful for simulating scheduling processes. C's structured syntax allows for clear implementation of scheduling, scheduling logic, and calculation of performance metrics such as waiting time and transfer time. Tools used C codes, logs, or Dev C++ or CGC compiler used as the main environment for writing and compiling the C program. C compiler executes the such scheduling program implementation. We take on one example, non-primitive primitive scheduling. In this problem, we are given four processes P1, P2, P3, P4. Each process has arrival time A, bus time B, priority P. Lower number equals higher priority. The goal is to schedule these processes using non-primitive property scheduling meaning. Once a process starts running, it continues until it finishes. At any point among the processes that have arrived, the one with the highest priority or lowest number is selected. Step 1. Time equals 0. Only P1 has arrived. So P1 starts execution first. P1 runs from 0 to 5 second. Time equals 5 by now all other processes P2, P3, P4 have arrived. Their priorities P2 priority 1 highest, P4 priority is 3, P3 priority is 4. So the next process is P2 runs from 5 to 8. Step 3. After P2 completes remaining processes P3 and P4 highest priority among them is P4 Priority 3. P4 runs from 8 to 14. Last process is only P3 remains. P3 runs from 14 to 22. Finally, Gantt chart 0 to 5, 5 to 8, 0 to 5, 5 to 8, 8 to 14, 14 to 22. Hmm. Next, I'm going to explain the code. The combines priority scheduling with the aging in C. It begins by defining a process structure that stores all necessary information for each process, such as arrival time, bus time, and priority, and completion time, waiting time, and turnaround time. It also keeps track of the process. The main scheduling logic is inside the priority scheduling function, priority scheduling function. Inside this function, this time starts from zero and increases until all processes are completed during each cycle. The schedule, which means the lowest priority numbers among those that we have already arrived. If two processes have the same priority, it breaks the tie using arrival time. The processes that arrived earlier is selected. Once a process is chosen, it is executed non-primitive, meaning it runs until it finishes. After completion, the program calculates its waiting time and turnaround time. A key part of the code is the aging mechanism. After every fixed time interval, aging interval equals 5, any waiting process gets its priority improved by decreasing its priority number. This primitive saturation by ensuring the long waiting process move up in priority. In the main function, the user enters the arrival time, bus time, and priority for each process. After scheduling is complete, the program prints a table showing arrival time, bus time, priority waiting time, and this is observation from our experiment, we noticed a clear difference between priority scheduling with and without aging. Without aging, the CPU always chooses the highest priority process first. Because of this lowest priority processes had to wait for long time. This increased both the averaging time and turnaround. Comparative evaluation. Now I am going to explain the comparative. This is the explanation of the comparative evaluation. In priority scheduling, the CPU always selects the process with the highest priority, which means low priority processes may have to wait for long time. In our dataset, P2 had the highest priority, then P1 and P3 had the lowest. Because of this, without aging, P3 waited the longest, which increased this waiting time and turnaround time. This is also showed a clear risk of